The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody, and welcome to this month's We Speak Linux seminar. Let me get this presentation kicking for you. And to introduce the group, we wanted to let you guys know that we are a group that teaches Windows administrators and developers Linux through things like presentations, blog posts, and peer support. And we're trying to grow a community of Windows administrators and developers that can transition into Linux in this cross-platform world that Microsoft is kind of bringing to us now with the new products and features and tools that they have available to us. And at the foremost of an administrator's mind should be security. And so this month we have a session from Alex Long on Securing Linux 101, so getting started. And Alex has opted to introduce himself, so I'll hand it off to him here in a second. But for the remainder of the session, I'll be available either in the GoToWebinar control panel, so you guys can ask questions there. Further, if you like, we are also have a Slack channel, and so you can join into the webinar chat channel. If you're not on Slack yet, there's a link for you guys to go ahead and join Slack. I'll be monitoring Twitter as well, if you guys want to hit me up on Twitter. And all of the sessions, well, except one where I messed up the recording, all of the sessions are recorded and available to you in our YouTube channel. So look for those there if you want to watch a session again or find something that you might have missed. We do operate on the first Thursday of each month. It's the first Thursday of the month, October 4th. Next month, we have a very special guest, Max Trinidad, teaching us PowerShell on Linux. Again, cross-platform world. PowerShell is now available on Linux and Mac if you're not if you weren't aware of that. And in the following month, in December, I will be doing a session on using OpenSSH for both Windows and Linux users. And so let's go ahead and hand it over to Alex to get started. So let's go ahead and change presenter. Let's find him in this big long list of people that are on the session. Alex, you should now be the presenter. And
thank you very much.
Go ahead and get going. I'll hand it off to you. Thank you, sir.
All right. Can everyone see my screen?
I certainly can. Hopefully everybody else can as well.
Very good deal. Thank you everyone for attending. Today I'm going to talk about how to get started securing a Linux server. Since we only have an hour, this isn't going to be all-inclusive, of course, but more along the lines of what do you do first? A little bit about me. I am the manager of DevOps, information technology, and information security for a Tulsa-based software company. I hold a GIA certification as a certified Unix security administrator. I'm also a member of the Oklahoma chapter of the Information Systems Security Association. There's my contact information. Throughout most of my career, I've worked for medium-sized organizations where the teams weren't large enough to really specialize, and everyone gets pulled in a dozen different directions at once. So I've had to come up with a strategy for how I was going to manage my Linux servers. And that's what this conversation is about, a strategy that I've come up with for how to at least get started with that. What I'm about to say will make a few of you cringe, but bear with me for just a minute. Speaking for myself, I've always been a fan of having my applications on a different platform than my databases. Having, say, your application on Linux and your database on Windows or vice versa may help slow the spread of malware across your servers. But this only means something if it's just another layer in a comprehensive security posture. Security through obscurity should never be relied upon on its own as a defense mechanism. So while having your application and database on different platforms may help against spreading malware, it's only going to be a speed bump to an intelligent attacker traversing your network. Conversely, you can absolutely have insecurity through obscurity. And what I mean by that is, I think most people, when they have something they're responsible for with little expertise in that, their instinct is to leave it alone out of fear of breaking it. And probably more the fear of not being able to fix it once they do break it. This leads to the software getting out of date, default credentials getting left on an application, and other things just sitting there quietly waiting for someone to exploit. So if you have some server, a virtual appliance, or other device sitting around off by itself that you know nothing about, you should consider that to be a hole in your security posture until you at least put forth minimal effort to ensure that it's properly secured. There's a few key things that need to be kept in mind regarding Linux devices. First and foremost thing to remember is that Linux does not equal security. Now, what I mean by that is you're not secure by sole virtue of running Linux. The Linux OS and applications can still have buffer overflows, coding mistakes, be susceptible to brute force login attacks, SQL injections, all those yummy things that attackers go after. If your Linux device is provided by a hosting provider or a virtual appliance that you downloaded, you cannot automatically assume that the vendor has taken the time to lock it down. Now, in many cases they will, but in other cases they won't. If it's their practice to provide a service that generates as little tech support requests as they can, then the device may have major security deficiencies in the interest of maximum user functionality. And then lastly, if you have a Linux application that you've installed onto your own server, the software vendor or open source project team is unlikely to include server hardening information as part of the installation instructions. For example, if you obtain a web application, the vendor may not provide recommendations for hardening Apache, Nginx, or whatever web server is powering that app. What that means to you is that you cannot and should not rely on the vendor to tell you how to secure the server that you're putting the application on. So if you have the mindset, but the vendor didn't tell me I had to do anything, well, no, they're not going to. If you want to have any reasonable level of security, you have to stay as fully patched as you're able to. Now, there are a couple of schools of thought when it comes to patching. On one hand, patches introduce risk to in the form of breaking an application. On the other hand, not patching introduces risk of compromise by not having patched a known vulnerability. To me, it's a much easier sell to the organizational leadership that an application or service had downtime because of a bad patch than it is to say that our data was stolen or encrypted because I didn't have a readily available patch installed. Now, obviously, this risk is different if we're talking about some sort of industrial control systems or something like that. So you do need to consider the device's role within your organization. So let's talk a little bit about how you obtain your applications that you're going to be running on Linux, because this is going to affect how thoroughly you're able to keep it patched. And for the purpose of this talk, this is going to include the application itself that you're installing, any dependencies for that application, and dependencies for applications that you're developing. With Windows, most software is available through an installation package, like a setup.exe or something like that. On Linux, such installation packages are less common. You gotta have a lot of different ways of actually getting the software onto your server. And there's an order of preference that I like to follow when deciding how to install it. And those are, when possible, always install from the package manager your operating system. For Red Hat-based systems, that would be Yum. For Ubuntu, that would be apt. If it's not available through your OS package manager, use a more specialized one, such as Ruby Gems or Python pip. And if it's not available through one of those, manually copying and extracting files. Now, checking out software from a repository like GitHub would fall somewhere between priority 2 or 3 depending on whether or not I was the one maintaining the repo or someone else is who's committed to keeping that software current. And then lastly, compiling software directly on the server as a last resort. And here's the logic for that. You have to patch the OS anyway. The more applications and packages that you can patch during these rounds, the less work you have to do later. I don't know about you, but I'm busy. And the less time I can spend installing packages, the better. This also has the added benefit of having update logs and the ability to roll back to previous versions if something breaks, mostly. Now, by using a specialized package management system, you can query for newer versions of packages, but more importantly, you don't have to manually search vendor or community websites for updates. You have one place to go to install them. By manually copying files, you know exactly what you're putting in place and what needs to be rolled back if you break something. Compiling. I am not a developer. I'm not too bad at writing Bash or Python scripts, and I can fake my way around PowerShell when I need to. But I don't have the time to figure out what's going on when I'm compiling from source. And sometimes what looks like errors in the compilation are irrelevant, and I've wasted a fair amount of time troubleshooting something that wasn't really broken. So when would you want to compile something directly on the server? And the answer is if you have another choice. If your package management repositories don't have the software you need, or if you have a need for a specific feature that only exists in newer versions than exist in these, then you may have little choice. And this also includes if you need an older version than is available in one of these repositories, which unfortunately is the case often. So do yourself a favor. When using an alternate package management system, or if you're manually copying files or compiling, create yourself an inventory document of everything that you're putting on your server. Then go to the vendor's websites or the community websites for those packages and subscribe to their mailing lists to be informed of software updates. It's the only way you're going to be able to know when security updates are available to apply. So let's start digging into actually hardening a server. Here's what we're going to cover. What to do first. The very first step to be performed when you log onto a new Linux device. We're going to reduce the attack surface of a server by removing unneeded applications. Then we're going to restrict the scope of the applications that are running. And we're going to automate the install of security patches and set up email alerts. What we're not going to talk about today, I believe in one of the earlier sessions, someone talked about the Linux firewall, but also talking about the firewall alone could eat up more than just an hour, so we're not going to talk about it today. Also, this is a 101, so we're not going to be talking about advanced subjects like SE Linux, intrusion detection, Kerberos authentication, and all that good stuff. For today's session, we have two servers, a Ubuntu web server and a CentOS MySQL or database server. The virtual machines are connected to have two network interfaces connected to a LAN and a backups network. And this is a fairly common configuration for hosted or managed servers. So what to do first? The first order of business whenever you have a new Linux server that you manage, if you don't already have one, create yourself a named user, create an SSH key pair if you don't already have one, and add your public key to the authorized keys file. It's bad practice to use the root user for logging into a Linux device, and bad habits are hard to break, so start off right, even if you're the only admin and even if you only have one Linux server. With SSH keys, those are a means of identifying yourself through public key cryptography and challenge response authentication. You can also set a passphrase on your SSH key that you have to enter when logging in. And an SSH key with a passphrase meets most requirements for two-factor authentication. It's something you have plus something you know. Also, you can use your SSH key for authenticating the network devices that support SSH, like your switches, routers, and that sort of thing. So you can get a lot of use out of your keys. Okay, so let's do this. I'm going to create myself a named user. Set myself a nice strong password. All right, I need to add the user to an admin group on Red Hat-based systems. That would be the wheel group. There we go. On Ubuntu, the admin group would be sudo. There we go. Now let's create an SSH key pair. For Windows users, the tool you're likely to use would be PuTTY. PuTTY has a key generator. I like to set my key to 4K bits, but we're going to leave the default of 2K for now. And you'll want to create an RSA key. We'll generate PuTTY key generator. You have to wiggle the mouse around in this blank area to generate some randomness. We'll do this for a second. There we go. We're going to set a passphrase. I'm going to use one that an idiot would put on his luggage. Save the public key. You can name this whatever you want. If you're using multiple keys, you would name it based on the functionality that you're using the key for. Private key. Keep the private key private. Think of this as a private key for a certificate or a password. Now this is what we're going to need right here. We'll come back to this in just a second. Come back here. I'm going to log in with the new user account. Long. Now, if you haven't been on if this is your first time logging in, you need to create the files and folders needed. And OpenSSH is a little picky with permissions, so you'll need to set those. Authorized keys is the name of the files. Copy the key, paste it. The key, the public key will be one line. If you see multiple lines, you're copying the wrong thing. And then the permissions on that file need to be 600. There we go. Now let's try it out. New session. We will see where's private key. let's make this a little bigger. Now it's prompting for the passphrase that I set on the SSH key. And I'm in. Make sure we have sudo access. And I need to type it. All right. Let me fix that. All right, there we go. Thank you anymore. Thank you. Let's get us a named user on our CentOS box. And you can see I've already gone through the steps for that. The steps are the same for adding the SSH key. We're not going to worry about doing that again. Okay, so we've created a named user. We've created our SSH key and added it to our user. Okay, next we're going to talk about reducing the attack surface by removing unneeded applications. Now, if you've installed the OS yourself, choose a minimal install and only install the packages that you need and you'll be fine. If you're obtaining a server from a third party or from a hosting provider, or if you're taking over a server that you didn't build, then it can be a daunting task figuring out what is safe to remove. So we're going to limit our efforts to just software that's actually listening on a TCP or a UDP port. Now our sample environment, our Ubuntu web server has a web application. Our CentOS database server is running MySQL and Redis. So let's see what's running on each. On our Ubuntu server, sudo netstat-lnptu. Netstat-lnptu will show you everything that's running on a port. And looks like we've got a number of things running. We've got POP and IMAP server, SSH, some system stuff, a web server, and MySQL. On our CentOS machine, looks like we've got a mail transport agent, POP and IMAP server, Redis, MySQL, and a web server, and SSH, and a couple of other things. We know we're not running a POP or an IMAP server, so let's stop and disable those dudes right now. And this is our database server. We don't need Apache running. And that list is quite a bit shorter now. And there we go. We've shortened the list of stuff that's actually listening on a port. And you don't have to sudo the netstat command. If you don't, it just doesn't show you the name of the program that's listening on it. Now, one question that comes to mind is, why don't we just go ahead and uninstall these? We absolutely could, but let's go off the assumption for a few minutes that we're unfamiliar with the application running on these servers. We could be disabling functionality that's actually used. So for now, we're just going to disable those services and make a note to come back later and uninstall them if we choose. Okay. Next, we're going to restrict the scope that the applications that are running are listening on. And the method for that is pretty much the same on across any Linux application. The main difference will be the syntax, whether the configuration is listens on versus bind to. Now, in our example, we have two networks, a LAN and a backup network. You could just as easily have a SCADA network, iSCSI, voice over IP, or a number of other things. So what we're doing here has practical uses in a lot of different situations. On our web server, our web application, nothing on the backup network has any business viewing the web application or connecting through SSH. So we're going to limit both of those. For Apache, that will be we don't have mod SSL installed, so we're not going to worry about these. If you're running SSL, then you would add your binding address on these as well. Subtle difference between Red Hat based and Ubuntu servers are the names of the running services. Okay, let's do SSH. Tap complete. we go. We're going to set an address 192.168.14.187. All right. So we've restricted the scope of both Apache and SSH. Now do yourself a favor. Anytime you change SSH sessions or settings, leave this session open, fire up a new terminal, and make sure you can still log in. Otherwise, you could find yourself being locked out of your own server. Okay. On this one, let's okay, so we've done SSH, so let's move on to MySQL. Okay, yeah. This is by the way, the default for newer versions. But if you have an old server, it may be listening on all interfaces. There's something on Redis. Okay. So we're going to have to hunt for the config for Redis, which is something that you'll sometimes find yourself doing, and we're not going to worry about that right now. What we've done here is gone from a list of several services, some of them listening on networks that they have no business listening on, and we've reduced our attack surface and reduced the scope of running services to only those networks that we intend those applications to be available on. Automating patch install, which to me is the most important thing that we're going to do here. A device is only secure as your ability to keep it up to date. And the tools that we're going to use to do those for Red Hat-based distributions will be yum cron and some of the commands from yum utils. For Ubuntu, we'll use the unintended upgrades package. Let's start with CentOS. We just need to install the packages we need. Sudo yum install yum cron yum util. All right, that's installed. Now we need to configure it. And the configuration file is etc yum cron. Let's see. Nope. Okay. First thing we're going to do is we're going to set the update CMD to security. We're not really worried about bug fixes. We're just worried about automating the security patches. You can certainly use one of the others if you prefer. Download updates, yes. Apply updates, we need to set that to yes. Random sleep. If you have multiple servers, you may want to set a value on this so that they're not all patching at the same time and saturating your network and your disk I/O. Since this is the only one we're doing, we'll set that to 0. Email from. This will be the from address on the email that it sends out with update reports. I like to set something that identifies this particular server, usually the host name at my domain. Email to long@domain.com. You do a comma separated list if you've got multiple admins. And then save and exit. And now we need to enable the service. And then start it. There we go. So this is going to put a script in SC cron daily that will actually be used for the updates, which this executes, I believe, at 4 a.m., plus any of the random sleep that you configured in the previous step. Now, some updates require reboots to take effect. Kernel updates, some libraries, such as glibc. So we're going to create a script to automatically reboot the server if required. Sudo nano etc or sbin check reboot. Okay, reboot. And I'll explain the command we're putting in here in a second. The yum utils package that we installed a few minutes ago has a utility called needs rebooting. When you run that, it will return whether or not the server has a reboot pending. And with this pipe shutdown -r, what this essentially says is, if this needs done, do this. Let's make that executable. chmod 750 fn check reboot. Okay, now we need to schedule this guy to run. Since our patches are going to install at around 4 a.m., I'm going to schedule it to run at 5. What do we want it to run at 5 o'clock sharp? Every day, every week, every month. 1, 2, 3, 4, 1, 2, 3, 4, 5. Root to run it, and it will run sbin check reboot. And that's it. Now let's move over to our Ubuntu server. Ubuntu is a little different. It uses a package called, or an application called unattended upgrades. So go app install unattended upgrades. And we'll see that it's already installed and at the newest version. So let's configure it. First one we want to edit is 50 unattended upgrades. Now, there are a lot of options in this file. We're only going to go through a few of them. The first thing that we want to do is make sure that everything except for, in this first block, everything except for security is commented out, because we're just wanting to automate security updates at this time. If you want to do more, you certainly can. Next. Let's set email. This is the address that we're going to send updates to, or send email reports to. You want to send these to yourself. Now, unlike CentOS, Ubuntu doesn't, by default, have a mail transport agent or transfer agent, think an SMTP server. So you will have to install one if you want to use email reports. You use something like Postfix. Okay, and then we are going to set automatically reboot to true. I'm going to set it to run at 5 a.m. as well. Save and exit. And there's a couple of other things we need to do. And I'm going through this pretty quickly. If you're running Ubuntu, what you'll want to do is just look up Ubuntu unattended upgrades, and you'll get a lot of documentation and some good tutorials on all the specifics. We need to add a couple of options to this file so that we can make sure that the that it does what it needs to do. And that's it. Now, something worth mentioning about automatically installing patches. Both Red Hat Enterprise Linux and Ubuntu Server LTS, the LTS stands for long-term support. Both vendors and both groups are committed to long-term support for the particular version of Red Hat or Ubuntu that you have installed. And what that means is that they're not going to do major version upgrades to packages such as the kernel itself, Apache, MySQL. So like right now, the version of MySQL on Red Hat 7 is 2.4, I believe. They're not going to upgrade that to 2.6 in Red Hat 7. So the risk of a patch breaking your application is reduced. And that's really what we're talking about here is what's the risk to your organization. And I think it's worth mentioning, this will make probably fire some people up, but you have to consider risk to the organization versus risk to generating more work to the admin. And that concludes it. I think now we can go ahead and open up to some questions.
So nothing's come in yet, but I do have a couple of questions for you regarding some things as we've passed through. So I totally agree with you with the patch first and then deal with what's broken later. I spent 2 days sleeping underneath my desk, getting rid of a malware in a production Citrix environment on a 0-day attack. And so, you know, that was back in the early 2000s. And so that's kind of one of the strategies that I've preached over the years is patch first and then deal with what's broken. Of course, testing obviously is a big part of that, but you know, it's like you said, it's easier to deal with something that's broken than it is with something that's stolen, right?
Right, absolutely.
The one thing that popped into my head, and I know you said you weren't going to cover SE Linux in the session, but this is kind of a constant battle that I have on the administrator side of the house, is you getting these scenarios where developer X is like, hey, my application doesn't work in the new server that you just deployed. And I Googled this thing and I found this forum post that said disable C Linux. And I'm like, you mean SE Linux? And they're like, yeah, that thing. And so how do you have that conversation with the developer? Do you know it's time for them to figure out how to make the application work, or is like, do you push back hard? Do you come off? Like, what's your approach or stance in those situations?
One way of handling that is determining who has more bandwidth, the developer or the admin. If the developer has more bandwidth, more time, push back to alter the code to make it work with policies that you have.
Right.
If your admin has more time, then SE Linux has a permissive mode where you can run your application and it will log what it would have blocked, parse that log, find out what's going on, and create new policies to allow the new features of the application.
Cool. What I guess another question for me is that's even not so beyond SE Linux, so thank you for that. What are you seeing for key management in SSH? What are kind of the common techniques that in larger enterprises with many servers, what are people doing with their public key management for those hosts?
So it is a key pair. You got a public and a private key. So any tools that you're using for managing certificates and their private keys would
Mhm.
certainly be useful for managing SSH keys as well. And I know there's a number of commercial products on the market and probably a few community projects.
True. That's a good point. Yeah, I think in since PowerShell went open source and is on GitHub now, that's one of the things that another PowerShell community member and I kind of evangelized for is if we could figure out a way to have key distribution, public key distribution for SSH keys inside of Active Directory as an AD attribute that we could just use in deployments. And I thought we're trying to get that some attention in GitHub. So go find that and upload that for us if you guys are interested in that as a feature. So, but do you have any other comments for the audience, Alex?
The only other comment that I have is, in my experience probably in the last 4 years, I mostly work exclusively with Red Hat.
Cool.
I've only had one case where a patch broke something, and that was a configuration issue. It was the SSL configuration was moved from mod SSL to a custom configuration file, and mod SSL from SSL.conf.
Yes, very familiar with that.
And then the SSL.conf, we removed it because the file was empty. A patch come along, saw that the file didn't exist, so it created a new one, and so Apache wouldn't start because there was duplicate entries. Right. That was the only time in the past 4 years that I've had a Red Hat patch break something.
That's cool. Yeah. Yeah. Jokingly, when I present about Linux and people ask like Ubuntu or CentOS or Red Hat, I'm like, oh, I use real operating systems like Red Hat or CentOS, and I just kind of don't comment about Ubuntu and Debian. But that's a personal preference, right? I think so. We're probably on the same page there.
Yeah, it's the tools are there. It's just which one you have the most familiarity with.
Exactly. Well, we do appreciate your time today in this excellent session, kind of getting us started in our security journey. So thank you very much, Alex.
You're welcome. Thank you for having me.
Alrighty, guys. Well, have a good afternoon, and thanks. We're going to sign off now. This will be posted on YouTube in the next couple of days, and we appreciate you guys coming. See you next time at We Speak Linux.